Hey guys, welcome to the Chapter 7 review video for the Chapter 7 test, which is tomorrow. I'm really glad we got an extra review day. So in this video, I'm just going to go through the notes basically that we made in class. This is almost exactly what I went over in class, but I wanted to go a little more in depth in some of the problem areas. So first, let's look at our equation right here. This is our equation we use when we're looking at geometric sequences. Now remember, a geometric sequence or a series of numbers is something that follows a pattern with multiplication being the common ratio. So let me just write one right here. So this one's pretty simple. But if it wasn't simple, you would definitely need to use your calculator. To find the common ratio, you're going to take a number and divide it by its previous number. So 4 over 2. In this case, it's 2. So that means to get from one term to the next, I multiply by 2 each time. So say I had a problem and it said I want the 12th term in the sequence. So I would be looking for a sub 12, and it would be equal to a sub 1, which is 2. This 2 right here, not to be confused with the ratio. 2 n times the common ratio. And then n is the position of whatever that number you're looking for is. So it would be 12 minus 1, which we know to be 11. So it's very important you do it in parentheses because if you don't, if it's a negative, it will be incorrect. It can be negative, you know that because it will alternate signs, positive, negative, positive, negative. So if it was like this, our common ratio would be -2. But I think that's good. You guys really caught on to that today. Um, you'll also you'll need to be able to create this equation from word problems possibly. So if it was saying that there's a certain situation, there was a certain culture of bacteria that was increasing at a rate of 3 times per day, or like it tripled in size each day. That size increase is what you'll put in for your R. But yeah, I think you guys are really gonna do well with that. And it's on your reference sheet. So if you forget that equation, it's on your reference sheet. No worries. Let's go into the next equation. So this equation right here is, sorry, this equation right here is our exponential parent form or standard form, whichever way you want to think about it. Remember we said our y-intercept is the A. So y-intercept is always like the initial value, starting population, something like that. And then B is going to be our ratio. We know it's exponential because it's raised to a certain power, usually x. And remember, this is important. I had a few questions about this today. If you're typing an equation into Desmos and it says something like x plus 2, when you type that into Desmos, you're going to have to put parentheses around the exponent. That's important because otherwise you can't type it. I saw someone figure out how to do it, but it seemed pretty complicated, so I'd stick to the parentheses. So we talked about the ratio, we talked about y-intercept. When we are looking at rate of growth or rate of decay, we're looking for increasing or decreasing. We're going to look at the b. If the b is greater than 1, it's going to be increasing or it's going to be a growth. Remember this, they mean the same thing. And if b is between 0 and 1, which is, oh, I'm sorry, you can't see, which is a fraction, remember? It's going to be a decay or decreasing. And if you forget, it's no big deal. Plug that equation into Desmos, see if it's increasing or if it's decreasing. What else? So this is the one we had the most problem with on the study guide is when it was saying that we had a growth of like 3%. What is the equation? So the exponential equation. So say our starting population was 5. I'm making this up. And it grew 3% each year. 3% growth. I'm going to either say one second, I'm making sure I'm going to say the right thing. Okay, I think I'm recording. Anyway, so similarly to how we found the percentage when it's given b, remember we either did 1 minus the percentage or the percentage minus 1, depending on if it was bigger or less than 1. We also know that the answer can't be negative, so that's a telltale sign. So to go from the percentage to our decimal again, remember it's not just going to be 3% usually. So since it's growth, I'm going to have to add 1 to it. And I will add it to the decimal version of 3%, 0.03. So our common ratio is going to be 1.03. Say I had said there was a decay. Decay. I would have done 1 minus 0.03. And I would have gotten something like, doing math in my head, not always easy, 0.97. So we know that's correct because if it's less than 1, that means it's decreasing in value. When we added 1 to it, we got 1.03. And we know that is increasing. So that would be increasing, that would be decreasing. Again, if you can't memorize this, it's not a problem. All you have to know is that if it's increasing, we have to make sure that it's within the right. Oops, I did not mean to erase that. If it's increasing, we have to make sure it's greater than 1. If it's decreasing, we have to make sure it's a decimal or a fraction. So you have to make sure your answer makes sense in that case. So I kind of skipped around there. I probably should have talked about the rate of growth and decay first. So I'll just hit that real briefly. So I already said if b is greater than 1, I've said this like 3 times. If b is greater than 1, it's increasing. B is greater than 1. I don't like that. If b is greater than 1, it's a growth. And if b is less than 1, it's a decay. By less than 1, I mean a fraction. So when we have that b value, say we have 7 times 0.84 power of x, we are going to find the percentage, the rate of growth or decay, the percentage. We have to either do 1 minus or the number minus 1. We can't have a negative answer. So in this case, we're going to have to do 1 minus 0.84, and we would get 16.16, 16%. Remember, you can just move the decimal place 2 spots. You guys were doing really well on this. That's why I just skipped over it. We would know it's wrong because if we did it the other way, because if you do 0.84 minus 1, you'd get negative 16, negative 0.16, which is not correct because we can't have a negative number. So that's a quick recap. Let me just talk about graphs real quick. And remember, you can skip through this if you don't want to listen to what I'm saying. Let's talk about graphs. This is what an exponential graph looks like. I'm going to use my pointer now. So when we have questions where it says, what is y doing as x is increasing? It'll be like, as x is increasing, and then have a blank about y is doing. So we're going to look at x is increasing. This is what I do. I use my eyeballs, and I look where x is increasing. X is increasing that way. The x's are getting bigger this way. So as I go this way, where are my y's going? My y values are going up. They are increasing. Now let's see what happens. There should be an arrow. Let's see what happens when my y's are decreasing. So my eyeballs follow the degree decreasing. The the x's are getting smaller. What's happening to my y's as my x's are getting smaller? Remember with exponential, they always get really close to 1 point, but they never quite touch it. So in this case, the y's are getting really close to probably the x-axis. They're probably getting really close to y equals 0. It will be clear. If you can't remember, graph your equation into Desmos, see what those y values are getting close to. Let me pause to think about what else I need to say. Okay, speaking of Desmos, if you have something that's asking for, are these equivalent expressions, plug it into Desmos, the original equation that it gives you, plug in all the answer choices. If they line up perfectly, they're equivalent. Also, if it's asking for a y-intercept, I would go ahead and put it into Desmos and just double check because you can never be too careful. Because if you ever have an equation that has something like x plus 3 it's a transformation. That's where the transformation's occurring, is right here. So it's going to change some of your values. So I would just go in and double check what your y-intercept is. You can't be too careful. You're not going to run out of time on this test. So let's go into transformations and then we will be done. So we've kind of beaten this topic till it's dead. So I'm going to go through it real quick. Remember, if it's in the parentheses, the x's are changing. If it's out the parentheses, the y's are changing. If you can't remember, you can graph it on Desmos and see what it's doing. So this is in the parentheses, so the x's are changing, which means we move left or right. It's negative. When it's x, it's opposite. We move right 1. Positive 1 means to the left 1. Outside the parentheses is the y, so we're moving down. We're moving up. Now this is a stretch. We only have stretches, vertical stretches to be specific. When we talk about multiplication like this for exponential equations, so this will be a stretch by a factor of 4. Remember that negative right there doesn't mean a stretch by a factor of -1. It means a reflection. And if you can't remember and it gives you the option of an original equation when it has all these translations occurring on it, you can plug all those in and see how it actually changes each time on those like multiple select ones. Speaking of how a graph changed, you might have to look at graphs and how they're just like multiple graphs like we had in the study guide, I think. And you're going to have to say, how did it change from f of x to g of x? You just look to see directionally what it did. You might also have to create a new equation where it might say like the graph moved up 3 and left 4. And you'll have to select probably like multiple choice what the equation is for that. If you can't remember, because it does look different, we didn't practice too much about creating these equations because we can use Desmos. But it's different because our x value, when we have to put it in parentheses, the x is an exponent. So it does look a little weird, but it's nothing that we haven't done before. But like I said, if you're unsure about anything, you can always just put it into Desmos and see what it's doing. My last tip before I say goodbye and good luck is that you can always put an equation into Desmos and create a table. That could be very helpful for a few things. Um, so yeah, tables on Desmos good. You might have to use a table in Desmos when you're looking at the common ratio as well. So I have no doubt that you guys are going to do amazing on this test. Thank you for watching it if you did, and make me proud. You already have. You got through quadratic, so you can definitely get through this. So you guys have a good night.